Sorry, I keep getting cut off here. So that 6 up above, we took half of it, and that ended up being what went into our parentheses. So this same thing is going to happen here. This negative 10 is going to go right there into our parentheses. We have this perfect square trinomial right here that's perfectly factored. We still have the 17 from up here, and we still have a negative 2. But what happened when I squared the negative 10 is that I got 100. So I've already added 100 to this side. The reason being because m minus 10 squared is not, you don't just square the m and square the 10. It's m squared minus 20m plus 100. That's when we multiply that binomial out. So I did just add 100. So I have to add 100 to the other side too. And so we may as well move that 17 over as well. So we're going to have m minus 10 squared equals 81 when I do negative 2 plus 100 minus 17. So m minus 10 squared is going to equal 81. To solve this, I'm going to take the square root of both sides. I'm going to end up with m minus 10 equals positive and negative 9. Now, I know we forgot about that from algebra, but square roots do have 2 answers, so we're going to honor both of those. And when I take this negative 10 and I add 10 to both sides, I'm going to end up with 9 plus 10, and I'm going to end up with negative 9 plus 10. So my answers are going to be 19 and positive 1, which would have been the same answers if we had factored from the beginning. But this allows us to, oh my goodness, I don't know why that's doing that. This type of solving allows us to solve problems that aren't perfect as well. So for example, let's take a look at number 7, which was the first one of these complete the square to solves on your worksheet. K squared minus 6k minus 51 equals 9. And actually, I'm just going to try to simplify things by adding 51 right now to this side, which makes 60. So now I've got k squared minus 6k. And that's when we're going to go in here and we're going to take that negative 6 and we're going to split it in half, right? So I'm going to end up with k minus 3 squared. But I have to take this negative 6 halves and square it to find out what I got to add to the other side, which is 9. So I've got k minus 3 squared equals 69. And this is one that is not going to factor perfectly. I'm going to take the square root of the left, I'm going to take the square root of the right, and I'm going to end up with k minus 3 equals the square root of 69, which I don't think that simplifies, does it? It can be divisible by 23 times 3. So no, it's not going to simplify. So k minus 3 equals the positive and the negative square root of 69. And then I'm going to add 3 to both sides. And I know it looks wonky, but that's a really accurate answer right there. That's my 2. So if we write out our steps, because I know it must have been a little confusing, the video getting cut off, and probably I got flustered. But we're going to take b divided by 2 and square it, add it to both sides. Well, really, we're going to have to just add it to the right. And we're going to end up with x plus b minus 2, b divided by 2, whatever it is, squared on the left, and it's going to equal whatever on the right. That's when we're going to take our steps with square roots. So hopefully that made sense. You may have to just look over it one more time or check out Khan Academy, but I am going to attach all 3 of these videos to Schoology, and hopefully they work out for you. And come see me or send me an email.